Okay, so to repeat my general announcements now that students have already been given time on page 26. Remember, again, we have a CFU this Friday, we have a CFU next week on Wednesday, and the test is scheduled for 2.5 days before Thanksgiving break. Remember, ask to take it on the 21st, that's Friday before, if you know you're not going to be here for those half days. Okay, today we're just going to do more practice similar to what we saw yesterday in class. I'm going to get through 3 problems, and I'm hoping that today will happen relatively quickly. That way I can get you all an actual substantial amount of time to work on your homework in class. And then you can also ask questions. I'll take home. So we're going to get right into it. At the beginning of a study, there were 250 bacteria. 4 hours later, there were 610 bacteria. Use the following formula to answer the questions below. So when I want to compute the growth rate, I'm using that formula. What I'm going to do is plug in the information they gave me. They told me in the beginning, there was 250. They told me 4 hours later, that is how much time. They told me 4 hours later, I ended up with 610 bacteria. The only thing they did not give me is the growth rate. They're asking me to find the growth rate. So the one thing they did not give me is R. So what I'm going to do is take the information they gave me and plug it in. So that equation literally says I started at 250. I'm growing by some amount that I'm not gonna tell you, hiding the growth rate from you. But 4 hours later, I ended with 610. So can anyone recommend what you should do first? Yep. Yep. And how do I get rid of that 250? We're going to divide both sides by 250. Okay, so if I divide the right side by 250, all I'm left with is 1 plus R to the 4th. On the left side, when I divide by 250, that I'm going to need my calculator for. I need to get what 610 divided by 250 is. So 2.44. So this is what you get if you divide both sides by 250. Now, what do I need to do next? Right now, I know some weird decimal, 2.44 equals 1 plus R to the 4th. So what do I do next? We want to solve for R. So get 4th root. If you want to get rid of the 4th power, you need to take the 4th root. Now, if you take the 4th root of the right side, all you're left with is 1 plus R. The 4th power goes away. Okay, so the whole point of what we're doing here is I'm going to take the 4th root and the 4th root. Now, the 4th root of 2.44, I need my calculator for that. I'm going to type 4, type math, go down to this variable root command. Okay, and I'm going to type 2.44. Now, as always, I go to the 3rd decimal. I'm going to warn you, this one's kind of weird. So pay attention on the rounding here. I would normally go 2.4249, and then I would stop. But what I need to do is look at the number after the 9. The number after the 9 is the 8, which means I have to round that number up. But 9 can't go any higher. If I try to round 9 up, it technically is going to 10. So what ends up happening is the 9 rounds up, which makes it a 0, but that pushes the number before it up 1. This is the correct rounded version. If you're going to stop after 3 decimals, you actually end up having to round it to 1.25. Right? So this is where I'm at. I took the 4th root of both sides. I got 1.25 equals 1 plus R. What do I still need to do? How do you get R by itself? Is it the glare? The windows are showing away. Folks, how do I get R by itself? It says 1 plus R. Subtract 1, exactly. If you want to get R by itself, you've got to get rid of the 1. So I'm going to subtract 1 from both sides. That gives me R equals 0.25. Now, this question was just asking you to find the rate of growth. So I am done. That is my final answer. But I'm going to use that to answer the next question. Okay? This says, write a model to represent the number of bacteria in terms of time and hours. So now I want to actually write an equation. Okay, So I'm going to take the amount, look, the amount of bacteria I have is based off of what did you start with? I started with 250. Notice I'm reusing that number. I'm using the same number that was given in the prompt. I started at 250. But now I'm taking the extra information I discovered. I worked hard to figure out the growth rate. So I'm going to plug that into my model. That's the whole point. So I know the growth rate is 25%. So this is the model. That model says I'm going to start at 250. That's the number of bacteria we had at the beginning. And I'm going to grow by 25%. So now I can answer the next question. So part A was, can you figure out the growth rate? Part B is, can you actually write the equation? Part C is, okay, well, now you got to use that equation. It says use your model, so use that equation to calculate the number of bacteria after 9 hours. So I'm literally copying what I did in part B, except I'm now inserting the number 9 for T. Right? So let me go to my calculator. I'm going to say, all right, I'm starting at 250. My growth rate is 25%. And I want to let this happen for 9 hours. And so that colony of bacteria is going to grow all the way to over 1,800. And the last one, I wanted to design a question that requires real world common sense law. Okay, part D, I will admit, is not something I've taught you. Part D is you have to be able to use your own understanding of the world to answer it. It says, how many bacteria would you expect there to be in 2 days? So we have a function that operates hours as to make a prediction for 2 days. So let me show you a wrong way of doing this. That is absolutely not the answer. This is absolutely wrong. If this is what you do, what you are predicting is how many bacteria there will be in 2 hours, not in 2 days. So can anyone tell me what number should I actually be putting in for that exponent? If you have a model that operates in hours and you want to make a prediction for 2 days, you need 48. This is the common sense sort of real world knowledge you have to be able to be willing to bring into the class. Okay. So I'm going to add here in green, because I'm not going to say you have to show that work, but you have that has to occur to you. That you have an equation that operates in hours and you want to make a prediction for 2 days. So you are plugging in the number 48 for the time in your equation, which is going to be a ridiculous amount of bacteria. Okay, if you allow it to grow at 25% in 48 hours, you're going to have over, what is that, 11 million bacteria at that point. This is, by the way, why it's very common to feel a little bit sick one day, and then you feel like absolute crap the next day. Because whatever's making you sick, whatever bacteria or germ is in you, it has the ability to grow very rapidly if your body is not successfully fighting it. All right, go ahead and turn the page. We're going to do 2 more problems, and then any time that's left over is donated to you all. Yes, ma'am. All right, so at the top it says, as you solve each problem, be sure to define your variables and show your work. In 2000, Maryland's population was approximately 5.3 million people. That's your starting value. Beginning in 2000, Maryland's population grew annually by an average of 0.9%. Do not make the mistake of calling this just 0.9. Remember, if you want to convert a percentage to a decimal, you have to divide by 100. So 0.9 divided by 100, that is 0.9%. If you call it this, that's actually 90%. 0.9 is 90%. So 0.9% as a decimal is 0.009. I'd say that's a common way that people are going to trip up. They're not going to realize that to convert that percentage to a decimal, you have to divide by 100. Okay. Now it says use the standard equation to model the Maryland population based on year. Start by identifying the values of each letter within the function. So they give me starting value, they give me growth rate, they didn't give me anything else. They didn't tell me how long I want Maryland to grow. They didn't tell me what the final value is. But the nice thing is, that's all I need to be able to write an equation. When it says write an exponential model, this is what they're talking about. And all you need to be able to do that is know the starting value and the growth rate. That's all you need. So I'm going to take the 5,300,000, plug it in for P. I'm going to take the 0.009 and plug it in for R. Okay, so P is the 5 million, the R is the 0.009, and this is my equation. So if you can read the problem and set up that equation, now you're set up, you can use it. It says, use your formula to determine the population of Maryland in 2011. So now let me be clear, do not type 2011. It would be wrong to plug this in for here. That would not be what you're being asked to do. In fact, let me just show you, because I'm genuinely curious. I don't even know if the calculator will display if this is going to grow so big and the calculator can't even display it. So this is wrong. Yeah, okay, so it's so big that the calculator can't even give you the full number. But this is wrong anyway. Can anyone tell me what number we should be using for time if we're trying to make a prediction for 2011?
We should have to get out and that.
Oh, interesting. So what Allison was saying is, well, we're in the year 2025, I'm gonna add that part. And so we have to go backwards 14 years. But that's not actually true. We would only need to do that if they talked about this is what the population right now in 2025 is. But remember, what did the problem say? When did the problem say Maryland's population was 5,300,000? That's in the original problem, folks. You have to be willing to look at the paper.
In Maryland.
In Maryland, what year was it when the population was 5,300,000? Oh, you're 1 0 off when you say 200. 2000. The problem tells you in the year 2000, this is what the population was. So if we want to make a prediction for 2011, how many years later is that, folks? 11. That's what you have to be plugging in. You have to plug in 11 for your time. Because we started in 2000, we're trying to make a prediction 11 years later. So bringing my calculator back up, let me delete the 2000 part. This is what we should be entering into our calculator. And so we make a prediction of not quite 6 million. That's 5,848,960. Although the 960 and Allison, this is kind of related to the question you were asking before. You can't really have a fraction of a person. So what I'm going to do is round to a whole number. And notice, because it's a 0.6, bless you, I'm going to round that to 0.1. Okay. So I would actually, let me erase this real quick. You can't have a fraction of a person. I'm just going to round all that to a 1. Right? I honestly don't even. Oh, there you go. So if you wanted to write it out in a slightly different way, if you wanted to keep the 5.3, that's fine. My concern here is for people who don't change the 5.3 to 5,300,000, they might forget that this is not meant to be 5 people. It's meant to be 5.49 million people. So as long as that makes sense to you, fine. You know, pick blue or green. I'm willing to take green if that's how you want to write it out. Question, right? And interrupt me at any time if you have questions. All right, last problem of the day. Ned opens a savings account that has an interest rate of 2.25%. I will tell you that 10 years ago, 2.25% would have been amazing. Nowadays, because of how high interest rates have gone, 2.25% really not all that good anymore. But remember, if you want to convert that to a decimal, you have to divide it by 100. So if I take 2.25 and divide by 100, that is what the rate is. It's not 2.25, it's 0.0225. Now, his initial deposit is $1,500. Use the formula to model the amount in Ned's savings account. Start by identifying the values of each letter. So once again, they did not tell me how long he was saving his money. They did not tell me how much he has as his final amount. They just told me what he started with and the rate that the bank is paying. And that's all I need. If I want to write out this equation, all I need to know is what did you start at? And what kind of interest rate are you earning? That's all I need to know, just those two numbers. And I can set up my equation. And if I'm able to set up my equation, then I can answer questions like the one at the bottom of the page. It says, according to your model, how much would be in Ned's account after, oh, I didn't want to do that. After 3 years. Okay, I go to my calculator, I say, all right, I started with 1,500. I'm gaining, so I'm gonna add to 2.25%, because the decimal is 0.0225. And then I'm gonna let this happen for 3 years. So he's got $1,500. He is gaining, so this one plus 0.225. And we're gonna let this happen for 3 years. I'm gonna warn you now, 2% is not a very high interest rate. And only letting it go for 300, I don't remember what this value is, but I'm guessing it is not very impressive at all. Like, I'm gonna be impressed if it's even above $50 in earning, $15.50. Oh, so it's about $100, a little bit better than I was expecting. Yeah.
Go like, well, that's me, point me.
Well, I'll tell you what, if we had let this go for, say, 30 years, well, now it's gonna double in value. You know, as opposed to only earning an extra $100. Time is your best friend when it comes to investing. Okay. So 3 years later, he's gonna have a little over $1,600. And we are done. So let's see. Oh, that's right, that's right. So that's why I'm looking at the wrong schedule. All right, so we are done for the day. We have not quite 20 minutes left for the period, but I'm giving that time to you all to work on your homework. Oh, sure, I'll zoom right back in. For anyone watching the recording, thanks for watching. Students should work on homework such as 26 for the rest of the day, or 25 or 24 if they haven't done those. Okay, the only homework in your packet that is now beyond the deadline is 21. That is the only one that you can no longer turn in. All right, thanks for watching. Have a good one.